Well, we've got a great topic tonight called tabular data. Now, we've talked about tabular data a little bit before. Basically, we're just talking about data or information giving in a table, hence the word tabular. The AP likes to ask things three different ways: analytically, numerically, and what they call tabular data. So we'll practice this quite a bit tonight, and then we'll get a little more practice tomorrow, and hopefully you'll feel pretty confident. All right, let's start off with question 1 here. The data in the table below gives selected values for the velocity in meters per minute of a particle moving along the x-axis. The velocity v is a differentiable function of time t. Now, before I even get into what the question's asking about, there's a lot we have to pull out of this. The first thing I say to myself is that key calculus where differentiable pops up, and I need to be looking for that because it's important to know if my function is differentiable or not. And the second I see that word, I make a nice imply symbol, my double arrow, and I say that also implies that my function is continuous. And that's key. The second thing that sticks out to me is they'll tell you who you're looking at in case you can't read the table. It does say it's velocity, and as of today, we have to be very, very cautious about our units. The AP is going to take a point off every time we screw those up. So let's make a note that we are in meters per minute. All right. Question 1 for this table. At t equals 0, is the particle moving to the right or to the left, and explain your answer. So typically how they'll break it up is they'll give you a point for your answer and a point for your explanation. Now you don't need to write a whole sentence, it doesn't hurt, but you don't have to. So all I'm going to say is I'm going to start with my justification. The second I see the words moving to the right or left, the first thing that pops in your head, hopefully you've said it to yourself already, is velocity. So I'm going to say v of 0. And now I'm going to go to my table. When the time is 0, I can tell that the velocity is -3. So I'm just going to say v of 0 is less than 0. Therefore, the particle is moving to the left. Okay, now how else could you say that? Well, you could actually say what it is. You could say v of 0 equals -3. Therefore, the particle is moving to the left. But typically, this is just perfect. V of 0 is less than 0. Question 2. Is there a time in the interval 0 to 12 minutes when the particle is at rest? Explain your answer. All right, so again, don't get nervous. Just find the key word, particle is at rest, and think of the justification. Well, that's when v of t equaled 0. Now, we're going back quite a ways. We have talked about this before. And let's take a look at our table. Does my velocity, this is velocity, does this velocity table ever equal 0? Well, your instinct might be to say no because you don't see a 0, but let's use some common sense. This graph is continuous. That means it goes from a height of -3 to a height of 2. Picture that. Oops. If you were at a height of -3 at 0, and at 2, all of a sudden you're at a height of 2, did your velocity, because you're continuous, did your velocity have to hit 0? Well, of course it did. And again, the only reason I knew that is because they told me my function was differentiable, which implied continuous. Now, there's a whole theorem that goes with this, and like I said, we haven't talked about it in a little while. So let's take, perfect notation down here. So I'm going to start answering the question by yes, v of t equals 0. I just kind of repeat that question back to them, yes or no. V of t has to equal 0. And now, how many times did we say? Well, we know it has to happen at least once it changes signs here. It could happen again, but I don't know for sure. So I'm going to say v of t equals 0 at least once. And my pen's kind of dying on me, I apologize. And now we have to state a little more, so I'm going to say that's on the open interval 0 to 12. And again, you can look this theorem up back in your notes. Now we have to justify why. So since v of t is differentiable, which implies continuous, and now we just state where we know it. We know, if I look back, v of 0 is less than 0, and v of 2 is greater than 0. We could probably say that in one little sentence. I'm going to say v of 0 is less than 0, which is less than v of 2. Therefore, I'm implying I have to hit 0 between v of 0 and v of 2. Then by the intermediate, value theorem. Whoopsie. V of t must equal 0. Okay, and we said we could, call that intermediate value theorem the IVT, but don't call it that if you don't know what it stands for. Practice writing it out. So again, this sentence isn't going to be the exact same on everybody's, but it should be pretty darn close. You do want to repeat the question back, say at least how many times on the open interval. Since v of t is continuous and differentiable, that has to be a must. That function has to be continuous. And then state where it happens. Then by the intermediate value theorem, v of t has to equal 0. Which of course means come to rest. Question 3. Use the data from the table to approximate v prime of 10 and explain the meaning of v prime and 10 in terms of the motion of the particle. Show the computations that lead to your answer and indicate the units of measure. So this is a very, very hot topic for us, and it's a very simple idea, I think. Just use some common sense. If you want to find v prime of 10, okay, and this is v, obviously what do you want to do? You have v, you want v prime. You need to take the derivative. Okay, so my goal is to take the derivative clearly at 10. Now, you don't have an equation to derive and plug 10 in, so you have to use something else, and we have to use one of the definitions of the derivative. So let's just recall what those are. We've seen them on our recent tests and such. We have f of x plus h minus f of x all over h, or we can say f of b minus f of a all over b minus a. Those are our two key definitions of the derivatives. Clearly, this one is what you've done your whole life. That's just your slope formula, and here's the actual definition of the derivative. So I'm going to use just the slope formula. Okay, and my goal is to, notice it says approximate. All right, I'm not going to get the actual answer, I'm just going to get an approximation, and it will always be an approximation when it's asked this way. So I need to approximate the slope at 10. Well, the easiest thing to do is say, okay, well, 10 falls between 8 and 12. So I'm just going to apply the slope formula in that section from 8 to 12. So my A is 8, and my B is 12. And again, I'm just approximating the slope between those 2 points. So all we simply say is f of 12 minus f of 8 all over 12 minus 8. And this notation is your work, your computation that needs to be on paper. Now we just look at the table. F of 12 is 5. And f of 8 is 7. So as I plug those in, I'm really just getting, so we said 5 minus 7 all over 12 minus 8. Now, the other thing you'll notice they said is you had to indicate units of measure. Like, I really believe this is dummy proof. If you can read the table, you can't screw this up. Okay, so the 5 minus 7, here's the 5, here's the 7, they're on the same line, and just read the units. It says meters per minute. Write that down. Meters per minute. Read the 12 and the 8. The 12 and the 8 came from this line, and this line says minutes. Write that down. So as I clean this up, 5 minus 7 is negative 2. 12 minus 8 is 4. I get negative 1/2. And now let's just write our units down. I have meters per minute. Obviously division means per. So I can really say that's negative 1/2 meters per minute squared. So we've computed our answer and we've included our units. So lastly, it said explain the context of the problem. We can say we found v prime, so we have found the acceleration is decreasing, and I know that because I got a negative value at t equals 10. Last part of the question, 4. Let a of t denote the acceleration of the particle at time t equals t. Is there guaranteed to be a t equals c in the interval 0 to 12 such that a of c equals 0? Justify your answer. So again, think about what you have and what you want. We are given a table of velocity, and this question is asking about acceleration. So in my head, I'm saying I need to be looking at slope. That's the first thing that pops in. I have velocity and I want acceleration. So again, I'm saying I need to find a slope that's equal to 0. All right, so I just think of my difference quotient or my slope formula, and I'm saying, is there ever a time when f of b minus f of a all over b minus a equals 0? Now you could sit here and mess around with all these numbers, or you could just use some common sense. How does a fraction equal 0? All right, not a trick question. What number do I want to have in my fraction to get 0? Well, basically, I need to have a 0 on top. I need to be 0 divided by some number. So I'm saying to myself, is there ever a time when I can get 0 on top? Well, if that happens, I have to have the same number minus the same number to get me 0. So I'm really just looking to see if there's a time whenever my velocity is the same number. And hopefully you're saying right here. Okay, if I compute the slope formula between 6 and 12, I should get a slope of 0. And that's the notation I need to show. So I'm going to say, of course, this is my A and this is my B. V of 12 minus V of 6 all over 12 minus 6 equals 0. And then I'm just going to show those computations. So I get 5 minus 5 all over 12 minus 6, which of course is 0. Now remember, the only reason I could use the slope formula was because they told me that my function is differentiable. Okay, if my function's not differentiable, I can't derive it or find its slope formula. Now, of course, this too goes with the theorem, and hopefully that C kind of gave the theorem away. So here's how your sentence needs to go. We're going to say yes, since V of t is differentiable, okay, so there's that key calculus word we need to throw in there. And now we just show our math in our sentence. V of 12 minus V of 6 all over 12 minus 6 equals 0. Then there exists at least one C in, what was that interval they gave us, 0 to 12, such that A of t equals 0 by the mean value theorem. So again, when we write these sentences, we're kind of just regurgitating what they know back to us. Just keep in mind the key thing you're looking is to see if that function is differentiable, then our theorems apply. All right, next handful of questions is based off this graph. Again, V of t is a differentiable function and it's measured in inches per second. So two things to sneak out: differentiable, which also means my function is continuous. Okay, differentiable tells me, of course, mean value theorem, continuous tells me intermediate value theorem, and it's measured in inches per second. All right, so question A. Approximate V prime of 35 and indicate the units of measure. So again, I say to myself, I have V, I want V prime. Okay, so common sense should tell you that we're just looking for the slope. So I'm literally going to do the slope formula. Now I have to approximate 35, so it's not going to be the exact answer, but again, I'm just going to approximate. It falls between these two values. So I'm going to apply the slope formula in this section. Okay, so I'm going to say my A is 30 and my B is 38. So I'm doing V of 38 minus V of 30 all over 38 minus 30. Okay, that's simple. I'm doing the slope of velocity to get V prime. Now, let's get those values and then we'll worry about our units of measure. V of 38 is 17 minus V of 30 is 21. All over 38 minus 30 is 8. Now let's grab those units. And again, this is what I'm saying. It's hard to screw this up. It says V of t is measured in inches per second. That's a rate, so that's my velocity. So that is my inches per second. Therefore, my time is measured in seconds. All right, so as I compute that final answer, I get a negative, what is that, 4/8 or negative 1/2 inches per second squared, or inches per second per second. Question B, is there ever a time when the velocity has to equal 19? So again, here's what I'm saying to myself. It's asking for v of t, and this is v of t. So I'm literally just looking at it. Okay, I'm not looking at slope. I'm looking right at this table. And I'm saying, does this velocity ever have to hit 19? All right, well, if I go from, and remember, I am continuous. We already stated that. 28 to 21, do I hit 19? No. 21 to 17, that's a yes. 17 to 20, that's another yes. 20 to 23, no, but 23 to 17. So I would say yes 3 times. And let's just work on that sentence. 3 times. Repeat it back. V of t equals 19. And let's see, that interval was 25 to 59. So I'm just saying that open interval, 25 to 59. Since v of t is continuous. And now again, state what you know. So I want to find the numbers that are between 19. So I'm going to say, let's see, we said v of 30 is greater than 19, which is greater than v of 38. So there's one time. Let's see, happened again, v of 38 is less than 19, which is less than v of 47. And we'll fit that last one in. Let's see, v of 53 is greater than 19, which is greater than v of 59. And I can say, obviously, all that's true by the intermediate value theorem. And again, if you don't know what that means, write it out. IVT, intermediate value theorem. Part C, is there ever a time when v of t has to equal 50? Well, again, if I follow these numbers, do I ever have to hit a height of 50? And that answer, of course, is no. I don't have anybody below 50 and above 50. Now, it certainly could, but I don't have to have somebody there. So again, I'm just going to start off by saying no and repeat it back. V of t does not have to equal 50. And I'm just going to say there are no known values 50 falls between. All right, moving on. D, must there exist a value c on the closed interval 38 to 59 such that v prime of c equals 0? Now again, think about what they're asking. They're saying v prime this time, and you have a table of v. So again, slope has to be going through your head because you want the derivative of that table. Now the other thing they told us specifically was just look in the section 38 to 59. Darn it. So just use that table, and you're specifically looking in the 38 to 59 section. So if I zoom in there, specifically in this section 38 to 59, the question was, do I have to have a slope of 0? Now, hopefully you can see that in your head again. If I get a slope of 0, when I do the slope formula, I have to get a 0 on top. And I think if you choose 3817 and 5917, you'll see that you get that slope of 0. Okay? Now, I'm going to say then, yes, v prime of c will equal 0, since v of t is differentiable. Then I'm just going to show my math now. V of 59 minus v of 38 all over 59 minus 38 equals 0. By the mean value theorem. Okay, so I am showing that there is a time the slope exists, and that is using the mean value theorem. So one thing to keep straight is if you're taking slope, you are using mean value theorem. If you're just looking at your picture, you're using the intermediate value theorem. All right, last question here. Must there exist a time t equals c in the interval 47 to 59 such that we have v prime of c equals -4? So again, they are saying your slope, but they specifically want a slope of -4. All right, so I'm not looking for a 0 slope. I'm specifically looking for a slope of -4. So let's go up and look at 47 to 59. Okay, so I'm just in, ooh, my pen. Just in the section 47 to 59. Will I get a slope of -4? Well, I'm going to zone in right at 47, 20, and 59, 17, and try my slope formula. 47, 20, and So let's say v of 59 minus v of 47 all over 59 minus 47. So that gives me 17 minus 20 all over 12. So that's a negative 3 over 4. A negative 3 over 12, or a negative 1/4. So the answer is simply no. There is never a time that exists such that this will happen. Well, hopefully that's enough practice for us tonight, and we'll look forward to seeing you tomorrow. Good night.